All right, guys. I feel like I just saw y'all. Getting back. Seeing y'all every other day. All right. So what we'll do is I have a rough draft of your test. I'll have to shorten it some because y'all only get 50 minutes because there's a class right before y'all and right after y'all. So that's all I can do. So let's talk about your test. Then I'll give you the opportunity to ask questions. And then if y'all don't have a lot of questions, I'll pick out some problems and we'll work through those just to make sure you were good. Okay. The good thing about testing 9 and 11 together is they're very similar. So a lot of times in 9, you were calculating Q. You're doing the same thing in chapter 11. So, as of right now, there are 5 multiple choice, but those are just like quick math problems. They're not the long, drawn out. Or I give you a compound and ask what intermolecular force is present. A lot of people have asked about vocab. I don't put like define what the enthalpy of fusion is. It's kind of like you have to know that word to like answer a question. Like there is like a phase diagram, you know, where you have your triple point, your critical point, and then your 3 different regions. It was what we did at the very end of chapter 11. So you'll have to navigate that and tell me, like, if I change the temperature from this to this, what phase change happens, all while looking at the phase diagram. And then the other non-math type question is I give you a set of compounds and you tell me which one has the highest boiling point and tell me why. Well, really all I want to know is X has the highest boiling point because its intermolecular forces are hydrogen bonding, and that's really strong. See what I'm saying? Then other than that, it's math.
Be able to recognize the formula with the name of the gases. So
No.
like P1, V1 equals C2, V2.
Like that's Bolzol. No, you don't have to know that. No. Okay, so then the rest will be short answer math. So I have to see work for you to get full credit first off. That's a good thing because if you don't get the right answer, you might get partial credit. All right, so right now I have 20 problems or 20 questions total on your test, but I think it's still going to be too long for y'all. So you can expect one heating curve like we did on Monday. One or two simple gas laws. So maybe using P1V1 or one of the simple gas laws. Maybe using the ideal gas law to find something. And then don't forget about the density equation. those will be quick and you just plug in, give me the answer. Don't neglect pressure units though. Make sure you know how to convert, atmospheres to torr, kilopascals, things like that. Then the biggest problem that you'll have for your gas chapter is where you have to calculate the partial pressure and the total pressure of a mixture of gases. That one will be a little time consuming, but it's not hard. Then everything else comes from chapter 9 and chapter 11. So let's see. From chapter 9, let's see, calculate the energy. I either asked you to calculate Q and W and then plug it into the equation, or I give it to you and all you have to do is figure out the sign. Look at that quiz we took for that. They'll be similar. Solve for delta H of a reaction. If I give you the delta H of formations, so it's just the sum of products minus sum of reactants. Remember? It's been a long time since we did that. Definitely know how to solve for Q. So most of the time it's Q MCAT. And work is negative P delta V. When you solve for work, make sure you always convert it to joules. I think as far as difficulty and time consuming, heating curve, the partial pressure of gases, and then if I give you one where I ask you to find the final temperature of two things that you put together, set the Q equals to the negative Q of the other thing. Those are going to be the three most difficult. Everything else is pretty straightforward.
Will there be any percent yield?
No. She was asking about gas laws. I think y'all had some homework problems that dealt with limiting reactant and that.
You don't want to do the average.
No. Yeah, there's some parts of chapter 10 that I skip over. Some parts of chapter 9 I skipped over too. Those will not be on your test either. Like mean velocity something. I don't know. I don't do that. Okay, so do we have any problems you want me to work out, or do you want me to pick the problems to work out? Yes.
So like the chapter 10 practice that you posted, like how are we supposed to check our answers?
Did I not post the answers? I'll do that today.
But some of them confuse me, like
I'll see. You said 2 and 3? All right, number 2 says, this is practice that I posted on Moodle. Says calculate the volume in liters occupied by 845 grams of NH3 at STP. There's two ways you can work this one. You could work this one using your ideal gas solve. Solve for V. Or because it says at standard temperature and pressure, you can use the standard molar volume. 1 mole of an ideal gas at STP is 22.4 liters. So what you do is let's convert this grams of NH3 to moles of NH3, then we can find liters. So grams of NH3, I'm going to convert to moles using the molar mass. The molar mass is 17.03 grams. Then once I've converted to moles, I'm just going to use this relationship that 1 mole of this gas, 22.4 liters. Let me write this on my answer key real quick so I can post it. 0.03 grams.
I saw it in the oven. So what would you put for
273. Standard temperature and pressure. Standard temperature 273, standard pressure 1 atmosphere. Let's see. All right. Number 3, 2, right? And I'm going to read this and I'm going to write the variables, not the whole question. It says a small bubble of gas rises from the bottom of a lake where the temperature and pressure, so we'll say T1 is 9 degrees Celsius, P1 5.8 atmosphere. To the water's surface where the temperature is 25 degrees C, so we'll make that T2. Pressure 1 atmosphere. calculate the final volume in milliliters of the bubble if its initial volume, so come back over here and add V1, is 3.4 milliliters. So we want to solve for V2. So we're using the combined gas law here. That's the combined gas law. Either rearrange it now to solve for V2 or plug everything in and solve for V2. What would y'all like to do? Rearrange first. All I've got to do is cross multiply to get everything on the top. So it's P1, V1, T2 equals P2, V2 times T1. If I want V2 by itself, I'm going to divide both sides. By P2 and T1. So now just plug in your variables. Just be very careful that you're plugging in the right one for both top and bottom. So V2 equals P1. We need to convert those temperatures everything else we can leave as is. Right, P1 for 1 milliliters. T2, 298K.
For T1, I got 282 when that converted.
For T1? Oh, that's right. I don't know why I put a 3 instead of a 9. P2. 1 atmosphere. T1, 282.
You don't care what I do if I just plug it in.
Right? It doesn't matter. You should get 20.8 milliliters. Yeah, I'll post this answer sheet today. Any other questions from chapter 10 while we're here? Yes. No, you could have converted it to liters. But I think the problem asked,
You have to put it down in milliliters.
yeah, it says calculate the final volume in milliliters. Do y'all want me to work a partial pressure? Okay. see. Look at number 61 in your textbook. Chapter 10.
Are there any mole fractions?
Yes. You'll have to use mole fractions for partial pressure. Right, this one, we're kind of going the reverse direction. We're given the partial pressures. We want to find the total pressure, and then we want to find the mass of each gas. So to find the total pressure, that's rather easy. Remember, the total pressure is simply all the partial pressures of your gas added up. So it would be 215 torr plus 102 torr plus 117 torr. We add those all up, we get 434 torr. All right, so there's several ways we could go about the rest. We could do the ideal gas law for each individual component. We could find the mole fraction of each, then convert that to grams. What y'all want to do?
Do the whole fraction.
Mole fraction, okay. All right, so if we do mole fraction, we'll do that first. Then we'll need to go back and determine the total moles present using the ideal gas law. So the partial pressure for each of these is found by taking the mole fraction and timesing the mole fraction by the partial pressure, or being the total pressure, sorry. So we just found the total pressure and we were given all of our partial pressures. So let's plug in both pressures and solve for mole fraction for all three of these. All right, so here are my three mole fractions. I cannot stop there though. Can't convert that to grams. What I need that. Remember, the mole fraction of, let's just say A, is the number of moles of A over total moles. Okay, so for each of these three, I need the moles, so this top number. So we need to solve for the total moles so that we can plug it into this formula for each of those three components of our mixture. All right, so we do have to solve the ideal gas law. But we're going to solve it to find the total moles. So this is for total moles. So we need our total pressure in atmospheres. So our P total, we got 434 torr. So let's convert that to atmospheres. The volume was given to me. I erased it. Temperature was also given to me. Then we know R. So we need to convert our temp to Kelvin. Right, plug everything in. I'll get 0.0315 moles, the total moles. Okay, I'm going to erase this down here at the bottom. All right, so if I have the mole fraction of N2, this is kind of my formula. So I know what the mole fraction is, so let's plug that in, 0.495. I don't know the moles of N, so I'm gonna put that as X. The total moles, 0.0315 moles. So multiply both sides by 0.0315 moles. I got 0.0156 moles of N2. While I'm here, might as well go ahead and calculate grams since that's what I'm ultimately looking for. Isn't this fun? Puzzle. I'm gonna do that. I got 0.437 grams of N2. Okay, now I gotta do the exact same thing for oxygen and helium. Go to totals. box my answers. I had 4 answers. That's about as difficult as they get. As far as partial pressure and gas falls go. Yes.
I have 2 from the shop in there, right? For the best one.
Okay.
That's 58 and 68. 58, I know it's really easy.
One mistake.
And then 68. I love the formula that I
58. I think I have my problems in a picture. '58 says carbon, no, charcoal. It's primarily carbon. Determine the mass of CO2 produced by burning enough carbon to produce 5 times 10 to the 2 kilojoules of heat. So let's make some room. All right, so we're given the equation. We're given this equation and we're asked to find the mass of this, so grams of that, if we want to produce 5 times 10 to the 2 kilojoules of heat. All right, if I produce 5 times 10 kilojoules of heat, would that be positive heat or negative heat? Negative. So this would be negative. If I were to plug this in the equation somewhere, I would use the negative. All right. Well, I don't know how much carbon is going to produce that, but I do know that for 1 mole of carbon, I'll produce that. So let's use dimensional analysis. If I want this, so if I want negative 5 times 10 to the 2nd kilojoules of heat, well, I know that 1 mole of carbon will produce negative 393.5 kilojoules. So my kilojoules cancel. I'll have moles of carbon, but I won't grams. So 1 mole carbon, 12.01 grams. Multiply that through and you get your grams. Again, if you did not know that this should be negative, when you get your final answer and it's a negative grams, you should know that that's a red flag. No negative grams, please. Did I work this right? Determine the mass of CO2. I determined the mass of carbon. Did y'all get 15.3 grams of carbon? Okay, so I basically changed the problem. If we had done what we were actually asked, if I could read, we would have done the same thing. We'll just do CO2. So let's do it. Everything stays the same, except it's still 1 mole of CO2. We'll give 393.5 kilojoules. Then just use CO2's molar mass instead of carbon. It'll be 55.9 grams CO2. I'm sorry. 68.
Essentially, it's just a big conversion problem.
On 68, so anytime they ask you for a delta E or a delta H, like they did in 68, basically all they want you to do is so in 68, they were asking you to find the delta E, right? Yeah, delta E of reaction.
Is that one in Canada? I just couldn't find it.
I don't know that it is. I don't think we did a practice problem like this, but your book likes to do this a lot. It also likes to do this. Same thing. I don't think there's one like this on your test. Don't recall seeing one, but just look over it just in case. All you're doing is you solve for Q. They gave you everything you needed to solve for Q. So Q MCAT. Then figure out your moles. Take your Q, divide it by your moles. That gives you the delta E of your reaction, or delta H. Yeah. For the next class, I'll try to limit them to problems we didn't work. So I'll post 2 videos for today. I'll post this one that we just went over and then some more problems from the next hour. Okay. I will be in my office this afternoon. If you need something, come see me. If you can't make it today, of course, there's tutoring, or I'll be in lab tomorrow from like 12 to 3. You can always stop by there too. Yes, sir. Yeah, using the ideal gas law, you sure could have.